Hi, my name is Diana Thomas, and I'm providing you with a little tutorial on the calculator that was provided by Drs. Candel and Breukelen in their paper on efficient sample sizes for commonly used trial designs. This calculator is designed for the case where you have two groups receiving an intervention, Group A and Group B. And if you have an intervention and a control, that also falls into this scenario because the control would be receiving the ad libitum intervention. On the left side of the calculator are the inputs and the right side are the outputs. So let's go over the inputs first. Similar to a power calculation, you put in the values or things that you would need for a power calculation. For example, are you running a one-sided test or a two-sided test? What's your significance level? For example, in this case, the default is alpha equals 0.05. Power, what's your power? In this case, power is set at 0.8, but you could set it at 0.9, 0.7. And then you would need some estimation of the variance of the outcome variables. Here, that's put in as a range in the ratio of the outcome variable variance on the low end and high end. And I pulled these numbers from calculations directly from the paper, so you can go through how such a calculation is performed. But they're typically based on knowledge from the literature, past data, or very good assumptions. The new thing in the calculator is below. It's the costs of per participant in Group A and the cost per participant in Group B. So that's new. That's not part of a power calculation. I'm going to go over in a second why that's here and how useful that is. Next one is the relevant difference in population means in the actual measurement of the variable. And the last one is a measurement of outcome variance. Now, if you know Cohen's d, that's part of the calculation you would need for effect size for a power calculation. This number would just be 1 divided by Cohen's d. So you can change it, for example, right now the Cohen's d is set at 0.8. You could set it to 0.2, and you would get a change here. So let's go over these changes first. Just power calculation. I'm going to show you a quick thing here. So if the cost of treatment A and the cost of treatment B is the same, the sample size remains the same, 78.5. So if I have 100 here, still 78.5. If I have 200, still 78.5. The budget increases because my sample size increases. But the budget increases because the cost is more per participant. But the sample size stays the same because this is what you would get from a standard power calculation. Now, if you have an intervention that has a intervention arm and a control arm, stands to reason that maybe the control arm is cheaper. So let's assume that it costs $100 per participant to run the intervention, but only $10 to run the controls. Maybe they're just coming in for a weigh-in. And what you'll see now is something new on the outcome side. The budget has lowered because it's cheaper to run my intervention, but the sample sizes are now not the same in the treatment group and the control group. I have less numbers in the treatment group and more in the control group. So this is not a balanced design anymore, but it is these are the equations that minimize that budget, which is really what you want from a sample size calculation. All the things that hold for power still hold here. For example, if I change Cohen's d to be a medium effect, the sample size goes down. If I assume there's a large effect, the sample size goes down further. So if I go to the small effect, the sample size is large. Same as if you ran a regular power calculation. If I change alpha to be 1% instead of 5%, sample size goes up. Budget goes up accordingly. If I change the power to be larger, sample size goes up. If I have it smaller, sample size goes down. So all the things that hold true for a regular power calculation are held true here. The new thing is that you have now a budget calculation and minimization of budget. So it's just one more addition to the power calculation, one more equation that you're trying to minimize, and that's the budget. So that's a tutorial on how to use this calculator, and I hope it was helpful.